please welcome Ali Sevük, General Manager of Sintek Heavy Industries, and Dr. Ahmet Hakan Benzer, Founder Partner of Minerva Engineering. David.
Good afternoon, everyone. Decarbonizing in heavy industry is one of the most complex engineering challenges of our time. For sectors like cement, reducing emissions is not only adapting new technologies, it requires transforming entire industrial systems while maintaining operational reliability. My name is Ali Sevük. I am General Manager at Sintek Group, and today I'm pleased to be joined by Professor Benzer, who is founder partner of Minerva Engineering and developer of Primary Mill Technology System. In the next few minutes, we will share Sintek's experience in delivering industrial projects, explain why reliable execution is critical in decarbonization projects, and introduce innovative solution of primary mill system. Before we move into details, I would like to briefly share the journey of Sintek. Sintek Group is an EPC contractor specialized in heavy industrial facilities. We have completed more than 30 major industrial projects across 4 continents, with the total contract value exceeding $1.5 billion. Our experience covers cement plants, power plants, steel facilities, and other complex industrial plants. Over the past 2 decades, Sintek has evolved from a regional engineering contractor into an international EPC company specialized in complex industrial projects. Throughout this journey, we have delivered major projects across cement, power, steel, and other industry sectors. Our focus has always been the same: delivering reliable solutions in challenging environments. As you will see in this timeline, each milestone reflects not only our growth as a company, but also our increasing involvement in large-scale projects, transformations, and around all the world. Today, this experience allows us to support cement producers in one of the most important challenges they are facing: the transition for lower carbon production. And this is exactly where our contribution become relevant. In all projects, schedules can be recovered, budgets can be adjusted, but a life cannot. At Sintek, we believe a strong safety culture is the foundation of our project performance. In fact, across our projects, we have achieved over 4 million man-hours without a lost time injury in the last 2 years. For us, this is not a static only. It reflects our culture we built on every site. Nothing we build is worse than a life. Whoever comes site in the morning should go back home in the evening safely. In large industrial facilities, quality failures are extremely expensive. Prevention is always better than correction, as you all know. At Sintek, our quality systems are built around full traceability, strict inspections, and comprehensive documentation. Our approval by the nuclear authority in Turkey demonstrates our ability to meet one of the most demanding quality standards in the industry, and we apply the same discipline across all our projects we deliver to our customers. At Sintek, our ultimate goal to create a long-term environmental, social, and economic value through responsible engineering. This includes reducing the carbon footprint of our operations, adopting renewable solutions on our project sites, and supporting environmental initiatives such as our Sintek Forest program. We are also very much proud to be the first contractor approved by a responsible program supported by the Turkish government's Green Deal compliance framework. At this point, I would like to briefly share a few examples of industrial projects we have delivered in recent years. Some of these projects involve the construction of new industrial plants as greenfield, and while others require integrating new technologies into existing operations as brownfield. Let me start with Simpor's Alhandra plant. vertical mill revision in kiln number 7, which is currently considered as one of the largest decarbonization initiatives in European cement industry. In this project, Sintek was responsible for the engineering and supervision of the vertical mill and installation of vertical raw mill installation for kiln number 7. This project required precise integration into an operating plant environment and while maintaining production continuity. We continued our work in Simpor, Alhandra plant in Portugal with another major upgrade for kiln number 7. This project included procurement and construction works for preheater and kiln with alternative fuel integration. We built a cement grinding station for Chimsa in Houston, Texas. Executing industrial projects in the US market requires strict compliance with local regulations, detailed planning, and strong coordination with multiple stakeholders. Despite these complexities, the project was successfully delivered on schedule within budget. For us, this project represents an important example of disciplined EPC execution is highly demanding in a highly demanding market. One of the most important EPC references in Turkey is Metsem cement, with a capacity of more than 20,000 tons per day, one of the largest in the region. Sintek participated as an EPC contractor for both plants of Metsem, and our continued collaboration with Metsem reflects the long-term partnership we aim to build with all our customers. Here we executed the calcium aluminate cement plant for Çimsa in Mersin, Turkey. As you all better know that these type of facilities require a very precise process integration, material handling design, and careful construction coordination. Following the successful delivery of the first plant in 2022, we were entrusted by Çimsa for their second plant in 2024. For us, this kind of continued collaboration reflects the most important indicator of project success: client confidence built through reliable execution. Please let me highlight some of our EPC turnkey plant references in Turkey. I believe you might have noticed that across our project portfolio, many of our clients come back with a new contract for their new investments after completing the previous one. In our industry, repeated collaboration is often the strongest indicator of successful project delivery. Working on nuclear power facilities requires an exceptionally high level of quality assurance, documentation, traceability, and inspection discipline. These projects operate under some of the most demanding regulatory frameworks in the industry, where safety and quality standards leave no room for an error. For us, participating in such projects demonstrates our ability to perform in highly regulated and technically demanding industrial environments. In addition to cement and energy sectors, we are also very active in steel industry. These projects include coke oven battery and material handling facilities for Erdemir and İsdemir, belonging to Oyak Mining Group, who is a major steel producer in the world. Such facilities involve complex thermal processes, gas systems, and environmental control units, which are technically comparable to CCUS projects. Following the successful delivery of the project in İsdemir plant, we continued our collaboration with Oyak Mining Group in Erdemir plant, once again demonstrating the importance of the long-term client partnership in our industry. Okay, the projects we have just reviewed illustrate the type of complex industrial facilities we deliver across cement, steel, and energy sectors. Today, however, these industries are facing another major transformation: decarbonization. Decarbonization is no longer driven by a single factor. It's a result of economics, regulations, finance, and market demand. In fact, decarbonization is no longer only an environmental issue. It is increasingly becoming a business and profitability issue for the industry. While talking about the decarbonization, we have to talk successful integration of technology, mostly in brownfield conditions where they must be implemented in operating plants while production continues without an interruption. And this is where EPC capability becomes crucial. Installing technology without stopping the plant requires careful integration with existing processes, strong construction management, strict schedule discipline, and a deep understanding of heavy industrial environments. And this is precisely the type of challenge that defines most of the projects we deliver to our customers. All of these examples lead to an important conclusion. Successful decarbonization projects require more than just technology. They require strong industrial execution capability. At Sintek, we combine engineering, construction, and operational experience to deliver complex industrial transformations. What we bring to our partners are strong industrial integration expertise and experience, value-added in-house engineering, a strong quality and safety culture, and budget and schedule certainty. These capabilities allow us to transform innovative technologies into reliable industrial solutions. Here you can see the main areas where Sintek contributes to the decarbonization of industrial facilities. We support plant process upgrades, carbon capture-related projects, waste heat recovery systems, clean care substitution projects, and alternative fuel implementations. These are all critical steps in reducing the carbon footprint of cement plants. However, decarbonization is not only about upgrading existing systems. It also requires innovation in process. Execution improves the plant, innovation transforms the process. And this is exactly where our collaboration with Minerva Engineering becomes more important. While Sintek brings the industrial execution capability, Minerva brings innovation in grinding technology through the Pamir mill system. And to explain this innovative technology in more detail, I would like to now invite Professor Benzer, who is the founder partner of Minerva Engineering. Professor, the floor is yours.
Thank you. Ladies and gentlemen, thanks, Arjam. It was a very good pass. Let me talk about the innovative approach to sustainable solutions provided by Minerva. Minerva is an R&D company of the group which based on the science, so based on the scientific scope, we are trying to bring some new idea, and at the end of the day, we innovate and we do the integration, especially in the brownfield projects. Afterwards, we implement. So all our solutions ends up with the commercial stages. That's why it takes a certain period. Right now, we have been working on definitely on the mechanical activation part of it for quite a while, and pretty much the 100% of those solutions have been achieved. But on top of this, not only do the mechanical activation for all the materials, we need to do some preparation in terms of getting the pozzolanic activity in a maximum way. So we are running on some separation and beneficiation technologies. So we pretty much completed majority of that step. We are working on the recycling part of it, especially on the demolition waste and how to achieve a carbon capture, especially during the recycled concrete period with our techniques. And also we are trying to develop some zero carbon recipes, not including the mechanical activation also. So starting from laboratory, we carry the problem to the piloting and then we implement industrially. Now, as an industrial solution, I would like to talk about the Pamir milling, which is a cutting-edge technology, and it's a technology starting from eco-efficient comminution down to decarbonization period. So chronologically, we started this project, roughly speaking, 20 years ago as a lab-scale project, and in the period, we end up setting up an industrial application at 2017 in Bursa plant. Afterwards, we made a bigger machine and we implemented in Adana. And now we made an even bigger machine to commissioning by 2026 June, which will be grinding slag. So if we have a quick look at how the mill itself, so you can see that there's a stir in it, and the grinding discs, which there's a rotating shift at a very high or variable speed. Afterwards, we have multiple stages of grinding in the system, and there is a recirculating grinding patterns, and the media is centrifuged to outside of grinding chamber, and we can achieve both frictional forces, as well as shear forces are quite important. That's why we can achieve a very fine grind, and we can easily implement very fine ball size within the system, down to 1 millimeter at the current stage. And we have a grinding chamber, and we have a product separator, which is a patented. That product separator keeps the balls inside the mill and lets the material flow out. How do we use Pamir, and what sort of usage areas we have? Definitely, when we started, we were focusing on the capacity increase and the energy saving, because upon that time, 20 years ago, that was the concept. And therefore, for cement grinding, for raw material grinding, it's an important step, and we achieved many rules, and we did lots of tests on that. Definitely, because of the fine grind, we can achieve an ultra-fine cement production, which also allows clinker factor decreasing. So fine grinding is one part of this machinery. But also, at the end of the day, we can have a control on the final product size distribution, which is affecting the quality effectively. So we can manage the size distribution. That's why the quality is an important factor. On top of that, also, especially for fuel grinding, that systems allows us to achieve fine grind, especially in the petcoke applications, which is helping shortening the flame length by fine grinding. In this sustainability solutions, definitely the clinker factor decreasing is the major part, and in that case, we are focusing on the mechanical activation. And how do we achieve the mechanical activation? The mechanical activation is the aim to exceed to a certain level of grinding after fine grinding to be able to create a structural change on the body. How do we implement this in our system? We have a certain material characterization technique. We need to know the mineralogy, because everything relies on the minerals, and we address the minerals. Afterwards, we have a certain test protocol. And in that test protocol, with the mineralogical data, we do mechanical characterization or mechanical activation characterization. Afterwards, the quality characterization, and we do the circuit design on purpose. When I talk about the qualification, it's a graph of energy versus finances. This is a typical result from a natural material. So in the first stage of the energy level, we achieve fine grind. There's a certain achievement at that point. If we continue to grind, size reduction is not achieving, and the agglomeration starts because of the high active surfaces. Afterwards, we start crushing those agglomerates to achieve the mechanical activation. So the energy level we define for each type of material, it's a tailor-made solution. Afterwards, we define the amorphization, the activation stages with amorphization, because rather than measuring the particle size distribution, we need to measure the structural change through the energy level. At a critical level of energy, definitely we define the amorphization, and that amorphization in our database correlates with the activation index. It's in series. As much as amorphous phases, especially on the silica mineral contents, we achieve the activation index, and through that activation index, we run our quality simulations to find out the best results. So this is a typical application of Pamir milling circuit. You can see that it's 3 mills in parallel. The reason that you can use 1 mill, 2 mill, 3 mills, it doesn't matter. But finally, you have a certain solution, and any type of material, byproducts, waste, mine tails, putzolans, or clays can be mechanically activated either in a recipe form or in different operational conditions. So on top of all these, we have been working a certain control system, which is based on the final product. So that will be an AI control system. The operational conditions can be adjusted according to the mineralogical characterization. So for different material types, for a certain recipe, we can take a control from the beginning, from the raw material part. In here, as in general concept, the Minerva measures and evaluates the existing performance, how to bring it to upgrade that performance. We have process models, because I said that there's a 20 years background, and we have, using those process models, we get some idea, we create some scenarios. Then we run our pilot test in order to demonstrate what sort of quality advantages we can provide. At the end of the day, we provide performance guarantee. We are not selling the system itself, we are selling the performance, either energy, quality, capacity, or clinker factor. In our simulation studies, just to identify these are the simulation results, we can predict the product size distribution that can be provided. So industrial data set based on the simulations plus pilot plant data set gives us the optimum conditions. And those optimum conditions, the mill itself has got a specification which you can speed up the mill or slow down the mill, which is the tip speed. We can change the ball charge. We can change the ball size. We can adjust the chemistry, the grinding aid, and we can adjust the feeding size as well. This is a proven technology because we have significant industrial applications within Turkey. These are the marks that's indicated on the map. In Ankara, we have a pilot mill, and in that pilot mill, we are doing the test, and we are providing the performance guarantees based on the results coming out from that system. So if you want to take part and if you want to get the benefits throughout this innovative approach, and if you are focusing on doing a capacity increase, achieving an energy saving, or if your problem is reduced carbon emissions, we can be in touch. And if you want to be a part of this change, we are ready to help you with our tailor-made solutions. Thank you.
It's now time for a very quick Q&A session as we are entering very close proximity to coffee time. So, beginning with you, Loic. May sound like a silly question, but how important are milling technologies in enabling decarbonisation? And do you think that it's a part of the industry that's often sort of underestimated by producers as a decarbonisation lever?
I think it's not underestimated, but the potential to reduce the CO2, optimize the grinding part, maybe is not known or not enough. So it's a daily work to convince people to step forward and to change the technology or to upgrade the milling plant. But anyhow, cement is a powder, or even binder are sold as a powder, so you have to grind.
Sure.
Even for calcine clay, at a given step, you have to grind.
Okay, excellent. And we'll just go to this question that's coming from the audience. I think that's perhaps best suited to you, Ahmet. Is the PAMIS solution suitable for the mechano-activation of illite-rich clays?
Yeah, and the answer is yes. I mean, unlike to the thermal activation, we don't require a certain silicon aluminum structure. So any type of clay can be mechanically activated. That's why I mentioned about the mineralogical characterization. Afterwards, we define the energy level. Of course, it's a benchmark of the energy versus the quality, but the answer is yes.
Okay. And Ali, for you, from the EPC perspective, what currently would you say are the sort of the biggest challenges when delivering a green cement plant in today?
Thank you. First of all, as I try to explain, we are working in different continents. So first thing is that we're trying to adapt ourselves for these different continents because every project has a unique expectations. For us, it's coming from the client, basically. Their expectations, we're trying to fulfill their expectations. But the major thing is that we are still, especially in Europe, it's very popular, but not all around the world. So that's why we are more focused on the European market now.
Okay, excellent. Well, I did again say speedrun, and I'm afraid that is sort of all the time we have. But thank you so much, guys. And please, a warm round of applause for our speakers and panelists. Thank you.